Hi everybody, this is part 3 of the chapter 2 videos. So this section is a little bit longer, but it is a review, important review of ionic bonding, covalent bonding, and the naming of ionic and covalent compounds, as well as naming of acids. So all of this should be review of things that we did before. So please take a look. If you have any questions, feel free to ask me in class. Elements. It can be ionic or covalent compounds. So a binary ionic compound, that's going to be a metal and a nonmetal, and a binary covalent compound is going to be two nonmetals together. All right, so let's talk about our standard binary ionic compound. So in that one, the cation is always named first and the anion is always named second. We spent a significant amount of time on this last year, so I don't want to spend too much time on the naming this year. I know I will continue to stress that you must know the names of your ions. It needs to be second nature. All right. Point 2 says the monoatomic cation takes its name from the name of the parent element. And 3, the monoatomic anion is named by taking the root of the element name and adding "-ide". So we're going to go through some examples. So if we look at something like KCl, so the potassium, the K is our cation, so it gets its name as potassium. And then the Cl, or chlorine, is the negative ion, the anion, and it gets "-ide" added to it, so we have potassium chloride. All right, our second example is magnesium, and then it has 2-bromine here. So we're going to give the full name to magnesium. Here it is, magnesium. And then we have our bromine here, and so we're going to give it the ending "-ide". Now remember, in ionic compounds, we're not going to worry about how many bromine this was. All right, all we have to do is remember that we have to equal out the charges, but when we're writing the name, there is no magnesium dibromide or 2-bromide or anything like that. It's just magnesium bromide. And then finally we have calcium oxide. You see that all of these have in common, they have one metal followed by a nonmetal. So those are binary ionic compounds. All right, so the metals and the compounds, so we can have an ionic compound in which the metals can have more than one type of positive ion. So these are generally the ones that really annoy people. So that charge on the metal ion can change. So we're going to need to put in that Roman numeral that tells us the charge on the metal cation. And so sometimes that gets a little tricky, but as long as you remember that the charges have to equal out, it must be a neutral ion in a compound, then I don't think that you will have trouble with this. Okay, so let's look at some examples. So if I know, if I have copper and bromine together, so I know that the charge on bromine is always going to be -1, so that must tell me that the charge on the copper is +1. So to write this, I have copper 1 bromide. So the number goes in the parentheses after the name of the cation. All right, so for our iron here, sulfur has a charge of -2. So our iron, we know, must be +2. So when we write the name, we have iron 2 sulfide. All right, and now down here we have lead oxide. Now we know that oxygen always has a charge of -2. So we're going to have -2 times 2, which is going to be a total of -4 here. So our lead must be +4. So lead 4 oxide. Okay, so we also will go through, we've had quite a few polyatomic ions. They have to be memorized. I know nobody likes to hear that they just have to memorize something, but that's just what it comes down to. So we have several of these to learn, but some examples include hydroxide, nitrate, and then in this compound we have two, because our cation is ammonium, which is a polyatomic ion, and then our anion is sulfate. So this entire compound is made of two polyatomic ions. Okay, let's go on to reviewing how we name covalent compounds. So remember, this is between two nonmetals. And it's pretty straightforward because the first element gets its name just as the element's full name. And then the second element gets named just as if it were an anion. So we're going to add that "ide" ending. And then we use those prefixes that we learned last year in order to tell us how many atoms are in the part that we're going to call like sort of the anion like segment. So if you remember those numbers, mono for 1, di for 2, tri, tetra, penta, hexa, hepta, octa, nona, deca. If you have forgotten these, I want you to review these, and you need to make sure that you have the 1 through 10 prefixes memorized. Okay, so if we look at naming these covalent compounds, so the first element gets just its name, so we have CO2 here. So we're going to write carbon is our first thing. And now our second thing is oxygen. So we're going to name it in a, now I keep saying anion, but remember these are not anions, but it's an anion-like method because I'm going to take the element and add "ide" to the end of it. So it's oxygen, so it becomes oxide. But because this is covalent, I need to say how many were there. Well, it's carbon and there's 2 oxygens, so carbon dioxide. All right, so let's look at the next one. This one has sulfur. So here's our sulfur. And then we have 6 fluorines. So that becomes the 6 becomes the hexa, and the fluorine becomes fluoride. Okay, the third example is a little bit different because this time I have 2 of the first element. So I need to tell someone that. If I wrote just nitrogen, that wouldn't be correct. There are 2 nitrogens. So I'm going to use that same prefix with my nitrogen, but I don't change the ending. It just remains as nitrogen. So I have di-nitrogen, and then I have 4 oxygens, tetraoxide. So we run into a little bit of a problem with things like oxide, and so we sort of leave the A-O combination becomes kind of a mouthful. So it's tetraoxide. You can work on the spelling there. Okay, so this is just a little flow chart for trying to remember how you're going to name binary compounds. So you can take a look at this later. Just remember that the main issue with naming a binary compound is this: is there a metal present? If there's a metal present, then it's ionic, and you use the ionic naming system. If there's no metal present, then you're going to use our prefixes and use a covalent based naming system. All right, so this is just another little flow chart that you can use to help you to remember exactly how we're going to go through those names. And this one stresses the idea of the polyatomic ions. And remember that those polyatomic ions need to be memorized. I know that there's a lot of them, but if you can learn them now, it will save you time and pain later. All right, Now that we've also been talking about naming, we need to consider the naming strategy that we're going to use for acids. Now, acids have basically a two-way naming system for those as well. So remember though that an acid is, you can basically tell you have an acid by the presence of one or more hydrogen ions attached to some anion. And that hydrogen is always written first. So when we name our acids, we're gonna look at two different systems. We're gonna look at, does it have oxygen or does it not have oxygen? So first we're gonna go through those that do not have oxygen. And they're really pretty easy to name those. They're going to start with the prefix hydro, and they're going to then add the suffix ic to the ending. So if we look at something HCl, all right, we can recognize this as an acid because we have a hydrogen ion out here in the front. So we're going to name this hydro. Here's the hydro, goes for the hydrogen. And now we have a chlorine here. We're going to get rid of the INE ending for the chlorine and add the ic. So we end up with hydrochloric acid. All right, now here we have a polyatomic ion. So you have to recognize that CN is the cyanide ion, but the same plan works here. We have the hydrogen out front. That's going to give us the hydro. Then we have our polyatomic ion here, which then gets the ic ending and becomes hydrocyanic acid. And then our last example has two hydrogens for every one of the anions. Now, when we're doing acids, you really don't need to do anything to worry about this 2 here. It still becomes hydro, and we would say sulfide as this ion, so it becomes hydrosulfuric acid. All right, so those are the acids without oxygen. Now, with oxygen, becomes a little bit different. When it has oxygen, you have to remember to think back to what the anion's name was. If the anion's suffix was ic, or if it was 8. So let's talk about, if it was ic, strike that, reverse it. Okay, so let's talk about acids that do have oxygen in them. First, I want to talk about any anions that ended in 8, because when you name acids, you have to consider what the initial anion ending was. So if the initial anion ended in 8, we're going to remove that and we're going to add ic. Now there's no hydro in the ones that have oxygen. So if I look at HNO3, so again, if it's going to have oxygen, these are all going to have polyatomic ions in them. So HNO3, so I have NO3, I have to think, okay, what was the name of this polyatomic ion? Well, NO3 is nitrate. So I'm going to take off the 8 ending, add ic, and I get nitric acid. All right, here we have the polyatomic ion would have been sulfate. I'm going to remove the 8, add ic, and I get sulfuric acid. And our last one, this is the acetate ion. I'm going to remove the 8, add ic, and I get acetic acid. Okay, so then if we had the initial anion for the acid, if it ended in ite, you're going to take the ite off and you're going to add OUS. So on our examples here, this time we have HNO2, and NO2 would be nitrite. So we're going to remove the ITE and add the OUS to give us nitrous acid. Here we have H2SO3. SO3 is sulfite. And so we're going to remove the remove the ite, and then we're going to come back and add the OUS. So again, with these, you just remove that ite ending and add the OUS. All right, so the flow chart for naming acids is really based on the fact of whether the acid has oxygen in it or not. If it has oxygen, then you're going to need to worry about what the ending of that anion was. If it didn't have oxygen, you're going to add hydro and stick an ick on the end. So I hope that with this chart will help you to be able to name those acids. And again, being able to name those polyatomic ions are completely necessary in order to be able to name these acids correctly. Okay, so now we have a couple compounds here that we want to look at and take a few moments to see if we can determine which ones are named correctly. So take a minute and try to figure out, and then I will show you the answers. Okay, so the only one that is named incorrectly is B. So you have to think about, okay, well, why is B incorrect? So often those metals, the transition metals that have multiple charges, really trick people and get them confused. So the issue is the oxygen. So this tells me that I have 2 oxygens bound to the titanium. Each oxygen is -2, and I have 2 of them. So this is going to be a total of a -4 charge here. Since this whole thing has to be neutral, the titanium has to be 4. So this should be written as titanium 4 oxide. If you got that correct, give yourself a pat on the back. You're doing good at remembering all your naming.